right, good day and welcome back to Everything Mathematics. I was specifically looking forward to today's video since I had the collaborative help of one of my co-workers. I did not tell her, but Miss John, I hope you don't mind me shouting it out here. Yes, this was one of her, what should I call it? What let us call when you make something for a debut. So this was one of our debut videos in practicing how to present PowerPoint, so make PowerPoint's presentation. So yes, I was excited to do this one today. Today we're going to continue with our series on matrices, and today we're going to look at how can we multiply matrices. So what are our objectives for today? Our objective for today, firstly, we're going to be able to, or we will look at the condition that has to exist for two matrices to be eligible for multiplication. Yes, we have to know that first. And secondly, of course, I'll be teaching you how to multiply matrices. So we'll be multiplying matrices. And what better way to learn this than by practicing a few of those? So what is the condition? This is the first thing that we need to know. So if I ask you to multiply two matrices, you can't just start by multiplying. You have to make a check. You have to check it out first and make sure that it could work. Let's look at that condition. For two matrices to be multiplied, guess what? The number of columns in the first matrix must be equal to the number of rows in the second matrix. Once those two conditions, or once these two things are equal, then guess what? The matrix is plausible for multiplication. So here we have an example of two matrices, right? We have matrix A and matrix B. And supposing now the question is asking us to multiply A times B, or of course you would see AB. If this is the case, if you're asked to multiply A times B, then you must check to see if this condition up here is true. Is the number of columns equal to the number of rows? How do we check that? First of all, we have to state our order of A. A is a 2 by 2. And guess what? B is also a 2 by 2. But let's look at what the 2 represents. This first 2 here is row by column. And here we have row by column. And according to this little statement I have above here, for two matrices to be multiplied, the number of columns in the first matrix must be equal to the number of rows in the second matrix. And this is true here. Look at it. The number of columns in the first matrix is equal to the number of rows in the second matrix. If these numbers are equal, therefore, guess what? Then we could say that these two matrices can be multiplied. You could multiply A with B. And I think I have a note after this still. So in essence, this is what we say. Once we have matrix A is a 2 by 2 and matrix B is also a 2 by 2. Therefore, the condition for multiplication is met since the number of columns in matrix A is equal to the number of rows in matrix B. So yes, it is possible. I will teach you one more thing here. I will tell you one more thing. In fact, a matter of fact, let me do that in the next slide because this is where most applicable. Let me just show you how to multiply, and then I will also tell you what should you expect when you multiply. So as I said, as always, you have matrix AB, not as always. In this case, you have matrix AB. So the first thing you do, you state the order of A. So A, again, as I did just know there, is a 2 by 2. B is a 2 by 2. So number of columns is equal to the number of rows. But you see these other two numbers here? Don't think they're just idle numbers. These other two numbers, when you combine them, it will let you know. We call these the resultant matrix. These two numbers here now will let you know when you multiply matrix A and matrix B, what the new set would be, what the order of the new set would be in terms of how many rows and how many columns. So in this case, because we have a 2 left here and we have a 2 left here, that means that when we multiply AB, since the condition is met, we will end up with a 2 by 2 matrix, row by column. And that is something we need to understand because not always we will end up with a 2 by 2. As a matter of fact, if I think I know me good enough, we have different examples and we're going to see different scenarios. But these are two things that I suggest, I advise that you always do. First and foremost, of course, check to see if it can be multiplied. And secondly, as a rule of thumb and for your own good, check to see what kind of matrix you will end up with as a result. In that way, you will know exactly what you should do or where you would put whichever number. Easier said than done. As we do it, you'll apply. Good. Let's look at the concept of to multiply. To multiply a matrix is a series of multiplication and addition. And the process goes like this. You are multiplying row by column. That's the process of multiplication. So let's call this one row 1. Let's call this one column 1. Let's call the other one, let's put it in another color. Let's put it in green. Let's call this one here row 2, which it is row 2. And let's call this one here column 2. Don't let the colors fool you too much. I just use the colors to guide you. So this is what you do. You do row 1 times column 1. Then you do row 1 times column 2. Then you do row 2 times column 1. And then row 2 times column 2. Ah, yes, I know. It sounds a lot tricky. But let's work it out. Let's work it out. And let's see if we could make sense out of it. So if we have to multiply AB. So we're multiplying AB. That is A times B. We know the conditions was met, but let's look and see how we multiply this. Look at the process. Row by column. So 4, I will write it like this for now since we learned it. 4 times 5 plus 2 times 4. That goes there. Row by column. The 4 multiply with the 5, and then you add that to the 2 multiplied by the 4. Row by column. That's what I did. Let's do the first row and the second column now. So I'm doing row 1 with column 2 now. So I will have at the top here, I will have 4 times 4 plus 2 times 3. Again, it's not rocket science. So row by column. So 4 times 4 plus 2 by 3. Row by column. And then we do the same thing now, but with row 2. Row 2 with column 1. Row 2 with column 1. So we have 3 times 5. It's a lot harder maybe to demonstrate. If I'm in a classroom, maybe I could touch this and show you. Right now I'm pointing it, but probably you can't even see me. But we have 3 times 5 plus 1 times 4. Row times column. This is a process that, believe me, the more you do it, you'll get used to it. 1 times 4. And then we do row 2 by column 2. And that will leave us with 3 times 4 plus 1 times 3. And this is how we multiply matrices. This is the process in which we multiply. And of course, we ain't done yet. From here, we still have to simplify. But I see simplification as an easy process. So this now is the same as AB is equal to, and I'll just simplify for now. 5 times 4 is 20. So that is 20 plus 8. Then we have here 15 plus 4. Then we have here 16 plus 6. And then we have here 12 plus 3. And ultimately that leaves us with AB being equal to 28, 19, 22, and 15. This is matrix AB. This is our final answer. Whew, I hope that process was clear, but don't worry, we have a few more to practice and then you have some to do for yourself. The more you do this, believe me, as I say, I usually tell my students this, the more you do it, the better you get at it. You just need to understand the process. Row by column, row by column, column, row, and you'll get it. So this is the first example. Let's look at the second example. Ah, oh la la. So here we have to see, first of all, if these two matrices are eligible. So imagine here that we want to multiply x times y. Imagine that. As a matter of fact, let me do the opposite way. Let me do the opposite. Let me do y multiplied by x. If we go to do this, look at what is happening here. Matrix y is a 2 by 1. And matrix x is a 1 by 2. So question, is this matrix eligible for multiplication? Yes, It is, because the number of columns in the first matrix is equal to the number of rows in the second matrix. So guess what? This is eligible. So when I'm multiplying this matrix, I will have y, which is a 2 by 1, 2 rows, 1 column, which is 1, 5, and I'm multiplying that by, I don't know how to put it like that. I could put it like this. I'm multiplying that by 2 and 4. And I wanted to notice that my resulting matrix will be a 2 by 2 matrix. It will be a square matrix. And we will see how that comes about. So if we have yx, I'm multiplying again, row by column. Row by column. It so happens in this one that row by column is just 1 times 2. Story done there. That's row 1 times column 1. Nothing else to add. That's it. Then row 1 is 1 again times row 2 is 4. So that's 1 times 4 and nothing else to add. Then I go row 2 times column 1, that will be 5 times 2. And then I do row 2 times column 2, and that will be 5 times 4. That's what it is, people. It is what it is. So yx is equal to 2, 10, 4, 20. Yeah, that is it. So that's a 2 by 1 multiplied by a 1 by 2. It's possible because the number of columns is equal to the number of rows. Good. If we go to reverse this, imagine we go to reverse this. Imagine the question asks us to multiply xy. So not yx, but xy, meaning matrix x multiplied by y. So no, x comes first. Let us see if that is possible. X is actually a 1 by 2. Yes, 1 row, 2 columns. Y has 1, 2 rows. Oh, hold on, look at this. 2 rows, yes, times, no. Something wrong. That means I make a mistake just now there. I made a mistake somewhere. This is a 1 by 2, 1 row, 2 columns. No, this is a 2 by 1. Yes, 2 rows. Oh my God, look at that. It don't matter how you twist and turn it, it will end up being the same thing. I like that. But if you multiply the other way around, you will end up with a 1 by 1 matrix, meaning you will only have 1 unit. And that's just what it is. And why am I doing this? I'm doing this to show you, or to let you know, that unlike when you multiply in real numbers, when you multiply in real numbers, the commutative law tells you that 2 multiplied by 3 is actually the same as 3 multiplied by 2. But when you're doing matrices, this is not always the case. X multiplied by y is not always equal. In fact, it's not always equal at all to y multiplied by x. So please remember that when it comes to multiplication. Of course, you could play up with it and do things until you're tired do things. But for now, this is something that you should know at the top of your head. Let's go. So that's the end of examples. Now we have some practice. I have 3 examples here, or rather 3 questions I would love you to practice. GH, find out what is G multiplied by H, find out what is H multiplied by T, and find out what is S multiplied by H. Of course, you need to apply the test and see if it's eligible, and if it is, then you follow the concept. Row by column, row by column. So of course, you pause here. I will not pause. I will move on. You take a pause and see if you could attempt it at this point. I will go. Let's go. So here we have number 1, GH. Look at G here. G has 2 rows and it has 1 column. So G is a 2 by 1. Let's look at H. Where is H? Oh, look at H right here. H has 1 row and it has 2 columns. 1 row and 2 columns. Yes. So guess what? These 2 matrices they are eligible. Why? Because they have the first matrix, the number of columns in the first matrix G is equal to the number of rows in the second matrix H. So it is eligible. And I also know that the resulting matrix in this, when I multiply these 2 matrices, I will end up with a 2 by 2 matrix, meaning I will end up with a square matrix. Good? Very good. So that's our background work. Let's work it out now. So we have G, let me write it up here. G, which is 9, 1, and we're multiplying that by H, which is 6, 6. One more 6 and we have the mark of the beast. Just like that. Right, so here we're doing row by column. Row by column. So row by column, first one we have 9 times 6. And then we have again 9 times 6. Row, column, row, column. It just so happened that you have 6 twice. So it's yes, 9 times 6 for the first one, 9 times 6 for the second one. And for the bottom, we'll have a similar scenario. Row by column. So row 1, row 2, which is 1, column 1 is 6 again. So it's 1 times 6. And then you have 1 times 6. And yep, this is it. So in this case, GH would have been equal to, let's see, 9, 6 I think is a 54. I'm subject to correction. If I'm wrong, well, hard luck. It's a calculation. That will be a computation error. Nothing else besides that, just an arithmetic error. Or I'll double check just now. I believe it's 54. 1 times 6 is 6, and 1 times 6 is 6. So yes, this is our final answer. Good. I just confirmed 9, 6 is a 54, yes. These things are simple, but sometimes you get carried away. So yes, this should have been our answer. I trust while you pause the video and you work it out, you got this here. Let's try the second one. Question 2. We have HT. So here we have H. Here we have matrix T. If we look at matrix H, again, let me look at the order first. Matrix H is 1 row times 2. Not times, sorry. 1 by 2. 1 row, 2 columns. And T, well, everybody knows a square matrix by now, is a 2 by 2. So here we have 2 rows, 2 columns. So the number of columns in the first matrix is equal to the number of rows in the second matrix. And in this one, our resulting matrix will be a 1 by 2. Meaning that the answer when we multiply H and T will give us 1 row and 2 columns. That is what we're saying here. 1 row and 2 columns. So in other words, the resulting matrix will look like matrix H. In essence, that's what we're saying. The resulting matrix will look like matrix H. So let's multiply these two matrices now. Let's write down matrix H. So matrix H, we have 6, 6. And for matrix T, we have 7, 2, 8, 5. And look at how this process goes here now. Remember, row by column. Row by column. So we go 6 times 7. And remember, we have to get a 1 by 2, so we know we'll end up with 1 row. So we ending up with 6 times 7 plus 6 times 2. Good? That's the first element in that matrix there, the first element. And then the second one will be the next one, row by column 2. So that will be now 6 times 8 plus 6 times 5. Believe me, this one will take some getting used to. Just follow the process, look at other examples and make sure you understand how we add, how we multiply. It's a very simple process, row by column. Once the column, as you can see, has more than one element, then we just keep multiplying and adding, multiplying and adding, multiplying and adding. That's what we're doing here. And then, of course, we simplify. So let's just simplify right here. So here we will end up with what? 6 times 7, that's what? 42. Yes, that's 42. So 42 plus 12. 6 times 2 is 12. And over here now, we will end up with 48 plus 30. Good? So our last final answer, let me put that in black there. Our final answer, let me just straight up here. So matrix HT is actually equal to 48 plus 12, 42 plus 12, that's supposed to give what? 54. And 48 plus 30, that's supposed to be 78, if my math serves me well. And this indeed is a 1 by 2. 1 row, 2 columns. I trust you got that as your answer. And let's see if we could wrap up with this final example. SH. SH. S is a 3 rows. So this is a 3 by 1. Let me put the S first because S comes first, right? So we have a 3 by 1 and we multiply that by a 1 by 2. Oh, very interesting matrix. So the resulting matrix here will be a 3 by 1. Sorry. Not 3 by 1, it will be a 3 by 2. So that matrix will look something like this. 3 rows, 2 columns. So you got something here, something here, something here, something here, something here, something here. 3 rows, 2 columns. That's what we will end up with as a result. So yeah, now that we sorted that, let's work it out. So matrix S is 1, 2, 6. And the next matrix is 6, 6. Wow, I use matrix H for all of them, I think. Right, and again, row by column, row by column. So when I do that, this is what ends up happening. The top here, row by column, I have 1 times 6. And that's it, because that's the only thing I have in that column. Then I do the other row, and there I will end up with 1 times 6 again. Second row, first column will be 2 times 6, and again we'll have 2 times 6. Oh my, this will be a boring answer. And then the third row, first column, will have 6 times 6, and row 3, column 2, will be 6 times 6. So in this one, we didn't have no addition to do, unfortunately. Yeah, so our final answer here should have been, let's see, here we will have 6, here we should have 12, here we should have 36. And since the two columns are the same, then here we will have, guess what, 6 again, 12 again, and 36. Because this is what we get when we multiply this here, and of course when we multiply here, we get that too. So this is matrix SH. And as we foresaw, it is a 3 by 2. 3 rows, 2 columns. So yes, this is basically how we go about multiplying matrices. Oh my, this video was lengthy. But I trust you got the concept. If you don't, of course, feel free to leave a comment. I will gladly help you or re-explain it in a different fashion for you if you would love me to. And of course, it's on you now to continue practicing, or maybe even look at other YouTube videos in which they might even clarify better how they multiply and add it as they come down the line. It's honestly, on my end here, it's a little harder to show because of my resources available. But that I know could be a little tricky as to when do we add, why did we add, why should we add here, or why we didn't add here, whatever. It all comes down really to the type of matrix that you have and how many rows, how many columns you have in certain matrices. But yes, I know it's easier said than done. So we're going to wrap up there for today. Again, feel free to subscribe if you haven't as yet. Like the video so that, of course, you will get some ratings. And turn on that notification bell so that you can be notified whenever you get the next one. Tomorrow, God's willing, Friday, we're going to look at the last one of this week, which is the adjoint. And we're going to take it up from there come tomorrow. So until then, you take care. Stay good.